Hi everyone, nice to see you here. There's quite a lot of people, right? I'm a bit nervous, but I believe it will be okay. Anyway, what I've noticed, right? You didn't talk about Azure from the first keynote session. Why? Okay, I don't hear it. Anyway, that was strange, but let's try to talk about it. I believe you've taken enough beer to hear about it and to talk maybe. So we will talk about Azure Serverless, right? As Anton mentioned, that previous keynote was about classic and solid way of doing things, right? In cloud, it's all good, but let's take a look on similar stuff, but from the different angle. And Azure Serverless. Before we will talk about it, I will a bit represent myself. Who am I? Because I forgot to add here the slide about myself. So I'm here. I'm Alex. I'm Aliaksei, Alex. And I'm platform engineer at Haleon. I'm working mostly with Azure Cloud, with automation in that, and with services in Azure Cloud. Probably that's it. I can be called like a DevOps engineer, the guy who can do stuff and can't do stuff. That's me. Yeah, okay. Our agenda today is here. We will talk about three main points which I've prepared for this session. It will be about Azure Functions, Azure Logic Apps, and Azure Web Jobs. So let's start from Azure Functions. So first of all, if for some reason you guys, and if you didn't work with that service, I could say that there is a similar thing in Azure, in AWS and GCP. In GCP, they are called functions, as far as I remember, cloud functions, right? In AWS, Lambda. So idea is pretty simple. You write in your code. You don't think about the underlying stuff. I mean, the services under the hood. You just write your code, for example, in the web browser, press the button, and it is executing somewhere and doing something for you. But more formally, Azure Functions is the service which provides you a serverless ability to think about your code using just your language you prefer to write your code on daily basis, and the service only provided by Azure. You can attach to your Azure function some trigger, some binding, which will start your function and which will connect your function to other services. And all this stuff is about Azure Functions. That's how it does look like from the more formal perspective. Okay. You can write Azure Functions in different languages with in different integrated development environments and using some specific tools to do that. So here you can find some similar, some maybe which you catch in, maybe it's your language here, or maybe using Maven, for example. Why not? I don't know why, but why not, right? So yeah, I used PowerShell some years ago, I would say, with Azure Functions. That was my only point of, let's say, touch with functions that time until now. Anyway, something about the background of functions. So functions is the thing which is running based on something, right? Basically, it's a set of virtual machines which are running in the background. There is some logic there. There's some connections, communication between those machines for scalability and other things, right? So to organize this in a more formal way and to make this possible to sell to customers, right? Microsoft organized hosting plans. The default plan for Azure Functions is the consumption plan, which is like the quintessence of serverless. Basically, you use that plan, you write your function, you execute it, and you just pay for it. You don't think about the scalability and maintenance of that function. Just, you have money, you pay your client. So there are a lot of other things, other hosting plans. Not a lot of them are presented here. Some of them are combined into one, like aggregated naming, like Kubernetes, for example. But the idea is to provide different capabilities to run your functions, to predict your, to use, for example, a limited budget and to understand that you will not be out of budget at the end of the month. So, for example, you can use a dedicated plan or premium one. Also, what I want to, in this table, I want also to be focused on the last row. It's called timeout. It is highlighted by red. Why it is so interesting for me? It's because you can find the indefinite sign in the most of the plans, right? That's quite interesting thing, but the reality not so beautiful. So let's start from the consumption plan. Consumption plan provides a timeout which is limited by 1 second from the left and 10 minutes from the right, with default value of, let me put this button. Yeah, it is working. This is the default values for each plan. So for the consumption, we have 5 minutes, for other things, 30 minutes. So without any additional configuration, you have 5 minutes of execution of your function with consumption plan. But you can increase it to 10 minutes. After that, your function will be finished its work. So what about this thing? This is for selling purposes. The guaranteed value is around 60 minutes to run the function, the maximum. You can run it more, but it is unsupported and it's your own risk. Moving on. Not okay. Yeah, very important feature of the functions is scaling of that function. Basically the scaling, how does it work? The root of scaling in functions is the piece of software called scale controller. It is in the, as I said, root. Why it is root of the function? Because from the one side, it is analyzing the signals which it is receiving from a lot of triggers, a lot of types of triggers, right? And based on the type of the trigger and amount and the rate, right, of calls from the left side, it is scaling the instances of, let's say, compute instances under the functions from 0 to 1 to 100 and thousands of stuff. That's how does it look like. The also interesting point here in scaling, this blue snowflake. I like the name Snowflake. I don't know, maybe because I want to work at Snowflake. Oh, that's my mic. Okay, Snowflake here. It's about cold start. This is a thing which you need to consider quite carefully before planning your Azure Functions solution. And not of the, for example, this default consumption plan work in that way that, for example, you're running your function. It is scaling, for example, from 5 to 10. Your load is quite solid for some time, right? But after that, your loading decreasing significantly, and you can find yourself in a situation when the amount of instances will be 0. It can be because function is not using anything. After some time, your scale controller is receiving some trigger to scale to one, at least to one instance. You need to wait for some time, and that's where these calls start making the change, right? You to avoid of this delay between 0 and 1 instance, you can, for example, use different hosting plans where, for example, dedicated, as far as I remember, or premium, where they have Azure provide the ability to have warm instances with always on like button. You will not be like affected by that cold start. Let's talk about common scenarios where we can use functions. First one is about for files uploads, right? Just a simple scenario. For example, you have your client, your customer, your partner, which is doing some bulk uploads, any uploads onto your storage account, on your storage resource. And you want to automate work, you want to automate the process, how to work with the amount of files which you received. For example, you need to update the metadata there. And you have some ETL solution, which will use those updated files and do with them anything. For example, delete them. You have strange relationship with your client. So here you can use Azure Functions because they will be triggered. For example, there is a trigger to react on the uploading of the file to the blob storage. And that file, you just write your function with some logic. It's triggered. You updated the metadata and remove, for example. Yep. That's how it can be. Another one thing is just a scheduler based on Azure Function. You have a database. You notice that there are a lot of duplications within some table. And you want, it's like a solid way how your application is working. Okay, we can just write the scheduler which will remove all the duplications from that. You use the trigger which is called, as far as I remember, recurrence trigger, which is starting your function each 10 or 15 minutes, and that's it. You're done. And you can make more complex stuff with Azure Functions, right? It's only maybe about your experience or about your imagination how you can use them. For example, you can build the quite simple chain of functions, where if one function do some stuff, it is called another function and another. Or you can use, for example, another feature of Azure Functions, durable function, which we will talk about it on the next slide. Basically, you can build a lot of more complex logic with that durable function stuff. It could be orchestrated in more smart way, and so on and so forth. And let's talk about durable functions. This is an extension of the Azure function. So generally, it's Azure function, but durable, meaning that Azure function, I haven't said about it before. Azure function is stateless by nature. When you work with Azure function, you need to understand that this function will be stateless, will be atomic. It will be it has to execute single operation, let's say lightweight and quick. That would be the perfect match with best practices which Azure want to provide to end user. Here you can build more complex stuff with saving the state, with rolling back of the failed transactions, and you can implement error handling like in a more, again, comfortable and native development way. Poo. Why I did poo? Because I wanted to show you an example. Yeah, because as for me it would be better understandable on the example. Imagine that you want to implement some process in your project, and the first step you decided to use functions for that. So you need to this is the chaining of the functions, right? You need to you design this diagram. Thanks this resource for doing that for me. Yeah, so I did that. This blue stuff. So I can put my face here as well. The idea is to execute functions one by one with some conditional relationships. So, for example, this is strict relationship. This cannot be executed because of the logic and so on. Why this is this important? Because it is the representation of Azure Queue, which is part of Azure Storage Account. So it is about the state. So to provide the output from that function to that input, you need to keep it here. And this is the problem, because you need to manage this. You need to manage this from here from code. You need to manage this as a resource. And what about error handling? What about the logical, execution to which storage I need to put the state, and so on and so forth. This is the meta code. Thanks, that guy. Do you know him? Okay. Why metacode? Because it is not working. Yeah, it is just to show you an example. Here, this function, which is like starting all the process, it is writing. Basically, it is writing some message to storage queue, and the next function is looking into the storage queue and running when something is appeared on that, any message is appeared there. It is starting doing some logic inside and put the output to the storage queue back. We can continue that at least to the, if we want to have more functions, we just write in function after function. Or we can think about the logic, but it is not related to best practices about atomic function and lightweight and quick execution. This is the example how it can be done with durable functions. I understand that it is even looking more complex, but it's just from the very first look, because all the execution of the functions is not is, how to say it, outside of managing the state, the storage queue, like it was in the previous slide. All the functions which are doing real stuff are running under the orchestration function, which is like a basis for all the relationship between underlying functions. And you can implement here error handling. Again, this, how to say it, relationships, conditions, if else, and so on and so forth there. And yeah, the meta code for that is looking better, I would say. Again, it depends on your experience and developer skills, how to organize it. Probably you can do, I don't know, you can replace your Kubernetes with functions, who knows. But this is about you writing your function here. This is the orchestration function. And from that function, you are calling all the stuff, all the subsequent functions, which you also need to define somewhere. This is the common place where you can do orchestration. This is better. And you don't need to think about this storage, because it is already under the hood. When you want to create durable function in Azure, you will, for example, in Portal, you will see that you need to create storage account. I thought the magic is about things that we don't need to create storage account, but it is. Okay. What I wanted to say about function cells. Okay, maybe you can say. Let's talk about logic apps. And this is another service in Azure, which will provide you an ability to run complex executions, orchestrate them, and don't think about the workloads under the hood. It's a bit different way how to do things rather than functions. We will have some comparison table at the end of it. And we will talk about it there. What exactly is Azure Logic Apps? It is a service which is, from my point of view and perspective, it is the root of integration between different systems. So you can put your logic app, like you see here, the example, that from one side you have some systems or triggers, from the other side you have systems or triggers, and you can build, like with logic apps, some complex workflow. And in an entry level, let's say, to understand how it works, you even don't need to write the code. You're just picking up the pictures from the portal and put some values for timeouts or for, I don't know, tracking the errors, and that's it. It is working from the first look, from the first step. Okay, it is working. Then to understand the Azure Logic Apps, you need to be familiar with some concepts. So it is globally, it is a workflow which consists of some trigger at the beginning, which is mandatory part, which is starting the workflow execution. Inside of the after the trigger, you can have actions, you can have conditional ways of executing actions, and that's how it works. Very important part of that is how to integrate Logic App, because as I said, it is integration thing. First option of that part of that service is integration. It is integrated with other services by using connectors. Connectors could be different types, right? And the first connectors type is built in, as you can see. They are quite simple in execution, and they're like why they're good and why we even speak about them. They are native for running Logic Apps. You can put your connector at the beginning as a trigger. For example, run your Logic App again by schedule, or you can again put your connector at the beginning of the workflow to listen some request type or to retrieve some headers, and based on those headers, you're executing the workflow. So this is an example of what kind of connectors you can have in built-in type. The more interesting thing is about managed connectors. Basically, it's just a wrapper on REST API for different systems. For example, you can see here the Gmail, GitHub, and other interesting thing. Maybe you're working with them during nowadays, right? So the main difference between built-in and managed connectors is because you need to authorize yourself before using these managed connectors, because it's another system, right? You need to have the connection and authenticate, authorize yourself to do stuff. This is quite big amount of connectors there, really. This is just, I don't know, 10% of them. And this is not actually a type, right? But it's worth to mention about custom connectors. The global idea of that, at least how I can see it, is just like an open source, right? For example, you want to, for your project needs, you heavily use the Logic Apps and you have no built-in or managed connectors to do things. You can write your own connector, right? You just write your API. You read the requirements how to write connectors. You write your connector according to the requirements, right? And it is finally working for you. But it is, for example, on your local team. What I would recommend in that case is to publish it and certify it. If it's really useful for your team, you don't know for whom it would be useful as well. That's how, again, this open source stuff is working. Just try to sum up what I want to say. If you write your custom connectors, please share them and certify. There are a lot of, certifications way how to do that properly. And if you want to read about it, please read. I will not prepare. I didn't prepare the QR codes for that, so you can just read. Sorry. Then some specification about Logic Apps. Again, how in the case with functions, you have kind of hosting plans for Logic Apps. They could be consumption Logic App and standard one. Consumption, like in the functions previously, it's a truly serverless approach. You just pay in for what you use, and that's it. Even if you created your Logic App, but you don't use it, you're not paying for that, only for execution. Standard one is based on some plan, so in that way you can predict your so you have a budget, right? And if you don't want to be out of budget, you probably need to consider the standard plan because you can predict your usage of the logic app. So what else? So it is quite a high level description. What is the consumption? What is standard? But from my perspective, the better idea is to highlight it on practice again, right? Here we have, this is the consumption. I'm sorry for that, right? It is not very visible from there. This is just ARM template, for example, Terraform template, Bicep, or CloudFormation one. And Pulumi. Anybody uses Pulumi? It's tested. Okay. I thought that I'm only one who doesn't use it. Okay, so this is just infrastructure as a code example, it's a representation of consumption. The idea is that you're using consumption logic app. You need to define the infrastructure as code, and within the field of that infrastructure as code template, you need to define your workflow, right? And you can separate it. And it's kind of hard to manage it on a scale. In the second approach, using standard plan, there is an ability to separate things, right? You write your infrastructure as code, so you write your logic app service, you manage it, you version it, you like think about it like it's a separate product. And another way, you're working on the workflow. You manage it, you can even keep them in different repositories and combine them on some CI/CD pipeline. That's perfectly working on scale. Okay, then the comparison between first two options. From my perspective, they are doing good things, but differently. And for me, it's not a good idea to compare them and to choose between them. From my perspective, it's always better to consider their usage together. In combination, they're working much better than without, each other. The last one about serverless in Azure, it's about Web Jobs. Does anybody hear about Web Jobs in Azure? Okay, who works with Azure? Okay, where you've been? Okay, anyway, does anybody hear about this web job? And cool. What can you please tell me for what is the purpose of using a web job? Can we use this microphone? You can tell about it. Okay. Okay.
As a background service.
For what? What is the purpose if you're using it? What is the purpose of using that?
For your calculation.
What creation?
Calculation.
Calculation of money?
Yeah. Everything.
Okay. In what context you use that web job?
As a background job, what I can do, like based on the web request, I need some job in background, so I can use web job for that.
In-app services, I believe,
Yeah.
right? That's the point, right? Because this is like serverless stuff, like a scheduler, where you can put your script or exe file or any Python binary, which can be executed only in scope of app service. For me, it's like a main disadvantage of that. I just wanted to highlight it because the implementation of that is very limited. But as you said, in your case, it is working like good, right? You don't need to use different resources. You don't need to implement functions or logic app. You just use that one, right? And it's working okay, let's say. Is it failing or not in your case? Sometimes. Okay. It can be done. It can be failing in different clouds as well. That's yeah. Okay, but The idea of the web job is to run the background task in scope of app services. App service, it's the platform as a service, which is basically like, in a simple words, is for, if you don't know, I'm sorry for the explanation, but this is just IIS or Apache, which is which you don't know, which you don't manage by yourself. You just prepare your code, push it there, and it is working. You're providing the web app for you, or I don't know, backend. And this is a part of app service. This could be used in two ways. It can be a continuous job or triggered job. From the naming, it is understandable what is what. There is a bit difference in the functional, let's say, context between them. But what I don't understand in that service, to write a continuous job, you need to put in an indefinite loop into your program. Okay. So triggered type of job, again, you can run manually or by some, I don't know, event. Event is quite big word for that, but anyway, let it be event. And it is, please confirm me that you running your web job on this type of app service. Yes. So the documentation of Azure doesn't lie. That's cool. Yeah, because I used WebJob a couple of times, but it was around 5 years ago. So I just read about them. I remember that this is very useful in limited context, but yeah, this. Okay, I will stay in that way. Functions and web jobs. I'm always comparing functions with all the stuff there. As I said, and I want to highlight that functions is the more convenient and the flexible way of doing serverless thing in Azure, but the main point of using web jobs, again, app services. So that's mostly it. Sorry for my clowning. That's how I'm hiding my nervous state. Thank you very much for your attention.